Welcome to this tutorial on moving average forecasting, which is one of the many smoothing methods that you can apply in forecasting. And we're going to discuss the other methods later, but right now we're going to focus on this one. So in the simple naive forecasting tutorial, I told you how to import the data that we'll be using today as well. It's called track data, and it collects, it's a collection of rides on track trains in thousands collected on a monthly basis, beginning in January 1991 and ending in March 2004. So that's what we have. Also in that tutorial, I taught how to prepare time series data for analysis and how to split the data for analysis to make sure that your model is sturdy, that it's really well built, and also to be able to compare this model to others, to be able to choose the best forecasting method given the data that you have. So here I'm not going to speak about it. You can just check out that tutorial. What I'm going to be speaking about is how to run moving average forecasting in SAS, and that's the only thing that we're going to be talking about. So moving average forecast actually does this. Let me just show you in this Excel file, right? We have our month and ridership. So the point is that we can decide actually that one data point, like we did in naive forecasting, right? When we did something like that, so this is naive. We can decide that simple naive, right? That one data point is not enough. And actually, simple naive corresponds to moving average of 1. When you take one data point divided by 1, you get your naive forecast of lag of 1. This is maybe not enough. So what you can do, you can actually take a few data points, one most recent and one step down, back into the history, and you can run your forecast taking those 2 points. So for example, to forecast our March, you can just, sum these 2 data points, divide them by 2, and that will give you your forecast, and this is how you're going to continue. So here you will start with January and February divided by 2 to forecast March. Here you will discard January because it's getting outdated, and you will take February and March to forecast April, and this is how you're going to be doing this. This is moving average of 2, the same will go for moving average of 3, and so on and so forth. Right now we are going just to run only one example, but you can of course play with it, and you can find maybe the model that will give you the lowest error after you have run many iterations. You can run, let's say, a moving average of 2. This is really useful if you have sudden shifts in your data. Like with the COVID situation, definitely a lot of sales could have dropped, right, on some goods, maybe clothes, for example, but sales, let's say, of cleaning detergents, especially, sanitizing gels and stuff, they went up. So maybe it doesn't make any sense to use a lot of points of historical data in this situation because, this is an exceptional time. And that's why it makes sense to do it this way, So, okay, we have this moving average forecasting. Let's get started. In SAS, we have this procedure called proc expand, and that's what we're going to do. Proc expand data equals, and if you're starting from scratch, by the way, remember to run the libname, which basically is a way of directing SAS to a folder on your computer where it can store the data sets that it creates permanently if you ask it to, and also where it can retrieve data sets in SAS format. So you will start with the libname, then give the name to the library, like BSTA477, for example, and in parentheses, quotation marks, you will have to indicate the path that you will get just here in the address bar, and after that just use the semicolon and you'll be done. So just remember to run it. This is very important. Don't just just type it in that and leave it as it, because if you don't run it, it never happened. Okay, so that's why it's important. Okay, great. So this is what you need to do. Now we are ready. Proc expand data equals bst 477 dot. And again, you should have created this data set some time ago. So if you haven't, just watch the simple naive forecasting tutorial and you'll know. So bst 477 untracked data tr, and we're going to create a new data set. We'll call it MATR, which is moving average training, and also we have to specify method equals none, because we don't want any methods to be applied to our existing data points. We want actually SAS to use the raw data that we have, and that's why you have to specify this option. And now ID is date, because this is time series. We also have to use convert. What we want to do, we want to take ridership and convert it into a new variable called forecast. And the options are going to be as follows. Trans south equals move over. Let's say we will use the moving average of 4. Why not, right? And we'll run it. And maybe here, let's also call it M8-4, because you can apply it. You can use different points. We're going just to run one, but you can play after that, and see which one is best, right? So that's what we have. And now let's see what SAS did, okay? Because you will need to understand it a little bit. It may take some time, but it's really important that you understand what it is you're doing, what it is that you got. Otherwise, why just, run this program? Why do we need you if the program can do everything by itself, right? So let's do it this way. You can see actually that the first forecast equals exactly to ridership. Pretty much it summed itself to itself, right? And divided itself by 1. And that's what we have. The second one is now the sum of these two data points, which is still not exactly what we need, divided by 2. And these are the same numbers. The next one is again not exactly what we need, because we need 4, we don't need 3. So we need 4, sorry. And this is what we have. And now the next one is exactly what we need. We need 4 points divided by 4. And that's what we have here. If we continue, we will have the same data points that exist there. The only problem is, so we have two problems here. First of all, these forecasts are not really useful because, we do not have, we do not need them, because we wanted to use the moving average of 4. So that means that we will lose these 3 points in the data. Okay, that's yellow is fine. We will not be able to use them like in the error calculations and so on, because we only wanted to use the moving average of 4. The other thing is that this forecast is kind of funny, because it actually uses the April data point as well to forecast April. And this makes no sense, because if you know all the data points, what sense does it make for you to forecast them if you actually know the actual values? So why would you ever want to forecast them? So what we will need to do, we will need to shift them a little bit. So we will actually need to lag them by 1 to get the appropriate forecasts, because otherwise, if we don't do that, we will actually, so here now we have this moving average of 4, right? The 4 missing points, and they are used to forecast May, and this is used to forecast June, and this one includes the data points from January to April, these ones from February to April to May, and so on. But they forecast the next period, not the same period, right? So this is the point. And in SAS, they do it in a funny way. So we will have to discard these 3 points, and we will also have to lag the 4th point, only lag a 1 to actually appropriate forecast. Otherwise, our errors can be a little bit lower than they should be. So after that, also what we're going to do is this. We're going to take this last forecast and use it to forecast everything in our validation data set. and it's going to be just 1 point. Sorry about that. This is how smoothing methods work, but that's all we have, you know. So this is how it's all gonna happen, and yes, so that's all, you know. This is what we're going to do. We're going to discard these 4 points. We're going to lag everything first. After that, we'll discard the points, and that's it. So let's go and let's do this. So don't save. Want to save changes? No. I was just using it as an example. So proc expand. Now I can expand this. We have MATR, and maybe let's call this not forecast, but let's call it MA right now, so that later we could create a variable called forecast when we use our lag. And that's what we're going to be doing now. So let's use our lag and let's do this. Okay. Now data MA4 TR the forecast, and the set that we're going to be using will be MA4 TR. Now we are going to create a new variable called forecast, and it's going to be a lag of the MA variable. And let's run and let's see what we have, you know, just to make sure. So we have our forecast now assigned properly, because we can see that our April data is used to forecast May. I mean, not the April data, but the April and May point is used to forecast May, which exactly should have happened, because, like I said, it doesn't make a lot of sense if you actually, you know, using April to forecast itself, right? You don't have to do this if you already know this value. So let's go, let's continue, and now we have this all done. We are going to stop here for a while, and now we are going to use the last data point, this one called the May, to forecast our next data set. So this is what we're going to be using. We are not going to be using this one, we are going to be using the one with the March value as well. So let's go and let's do this. Validation, or how do we say that? Moving average, MA, forecasting, validation data. So let's do this. And first of all, we need to subset everything, and we will only need to keep the last point here in the data, right? So let's do this. And to do that, we need to set data, MA4, let's say for example, and set is MA4 TR is good. And also we need to specify where, and where, yeah, date equals March 2001, date equals 01 March 2001 date, and run. So that's what we have, right? We have date MA ridership. And now let's continue. So we can see that we do not need ridership, we do not need the date, we only actually need our MA value. And that's what we're going to do. Let's go. Also, we are going just to keep one variable, but we are going to rename, rename that MA variable. Okay? Rename equals, rename, and it will be, yes, rename equals, now we'll have to say this equals to forecast. Okay, that's exactly what we needed. And now we can only keep one variable here, so keep equals forecast. And that's all we need. So now we have a data set with only one data point that we're going to extrapolate to the full validation data set. So let's go and let's do this. Now let's take our validation data, this one from the BST477 library. Again, right click, Control C, later we'll do Control V. We'll call it data MA4 validation, let's say forecast. And the set that we're going to be using will be BST477. And this is the data set that we have here. So track data V. And we are going to call again if underscore n equals to 1 and set. And we are going to be using the set that we just created called MA4, right? And let's run and let's see what we have. Yeah, perfect. So we have again our 36 data points that are exactly identical, which is okay, unfortunately, for this kind of forecasts. And now let's come back to the previous data set, this one. I will just run it. And let's also do some, adjusting, right? So all we need to keep is the forecast variable. We also want to discard these 4 points because we don't need them. Because these lines are kind of useless, right? So we will have to say that where date is greater than or equal to May 91, or where date is greater than April 1991. Okay, so that's what we are going to say, and that's what we'll say that where date is greater than, and I always forget, April 1991. One, April 1991, D, and that's one piece of the puzzle. Let's run, let's see how it works. Okay, so that's what we needed. But you know what? Let's maybe do it not here, but let's do it actually here at this point. Where equals, and now we'll have our date over there and the semicolon, so that we actually have it in the output, so that we do not have any missing points, Perfect. So now we have this correct forecast and stuff. And also, let's add keep equals. And what we want to keep is pretty much date and forecast. Or maybe drop. Drop equals MA. So we have now our date, our ridership, and our forecast for the validation data. We do not have 4 data points, which is okay. And that's exactly what we needed. That's it, so now we have our forecast and they are perfect. So now actually what we'll have to do, we'll have to calculate our errors just to estimate the model, how to assess it, right, how well it performs. And again, in the previous tutorials as well, I talked about how these errors, like what these errors mean. I talked about other things, but we can just go over them really quickly. We have 5 errors that we are going to be calculating. One is MAD, mean absolute deviation. Then we also have mean squared error, square root mean squared error, also mean absolute percent error and mean percent error. And all of them have different ways of calculating, and we'll have to do it in steps. And the first step will be just to calculate the difference, but with different values, right? So we'll calculate the absolute value of the actual minus forecast, also the regular value of actual minus forecast, also the squared value of actual minus forecast, also the proportion of the absolute value of actual minus forecast over the actual value, and also the regular proportion of the actual minus forecast over the actual value. After that, we'll have to sum them up, and then we'll have to find their mean, right? We'll have to divide them by the number of observations in the data. And that's what we're gonna do. Let's start. We'll have a few variables. I'm gonna just actually go there and copy them from the previous program. Abs, blah, blah, blah. So here. So here we have our abs, so they equal to the absolute value of the difference between ridership and forecast, and so on. So we have all of these that we discussed. So this is abs, this is ridership minus forecast, this is div2 squared, right? This is div abs, because we have a division here, and this is div reg because we have a division here. Great, so now let's run it. And this is what we have here. We'll have all these values. Now we need to sum them up. To sum them up, because we have the sum in our equation, we'll just run proc means. So summing the training values. Proc means data equals, and we'll have to use the MA4 PR forecast. The variables are going to be abs, div2, because we don't have anywhere where we need to sum just the actual minus forecast. Also div abs and div reg. We also want to create a new data set, so we'll have to say output out equals, and let's say MA4 PR, and let's go sum. And also the statistics we are looking for is sum, and we need to specify after the slash the option auto name, because we would like SAS automatically to add the suffix underscore sum to the names of the variables once it calculates the stats. And let's add run. And also we don't want SAS to print anything for us, so we'll say no print. Great, so we have all of these values summed up for us, and now we are ready to for the final step. So here, calculating training errors, and let me just say that this is a moving average process that we are working with. And again, we'll say data MA4 PR errors, or error, I think error is good. The set we are using again is going to be our MA4 PR forecast, and again we'll have to call this set to add the values so that we could use them for calculation. So if underscore n equals 1, then if underscore n underscore equals to 1, then set, and we're calling this data set that we created. And we can say run, and after that we'll just check what we need to do. We'll just, plug the values into the formulas and we'll be done. So perfect, we have our correct frequencies, we have all of this summed up. Now let's go, and let's just create everything that we need. So n equals underscore frac underscore. Also we need to calculate all of these errors, right? So the first one is med, then we have MSC, then we have RMSC, MAPE, MPE, and we'll also need to create a format. I'm doing it because I typically forget about the format, and it's not the best thing ever. So med is using the absolute, which is summed. You can actually see that it has the suffix abs underscore sum, div2 underscore sum. So the suffix is added, we don't even need to look back, we are going to be using these summed values, right? So it will be abs underscore sum, over n. And that's how we are going to calculate the mean, right? So for MSE, we need the square difference between the actual data point and the forecast, right? So it will be the sum square difference over n. RMSE is just the square root of MSE, only one x, and MAPE is actually the absolute proportion of the actual and forecast difference between the actual and forecasted observations out of the actual value, right? So that's why we'll do div underscore abs underscore sum over n, and the MPE is just different from MAPE by the absolute or not absolute value. So it will be div underscore reg abs, or sorry, div underscore reg sum over n. And the format, it's good that I have it here, you see, it reminded me a bit about it. We're going to use percent because MAPE and MPE, they should be in percent, and so we'll apply the format percent 10.2. And that's how we're going to get what we want. Great, so this is what we have here, and now we are going to actually do the final step. We're going to only keep one row, let's say May 1991, and let's keep it here. It doesn't actually matter, so we can put it here. You have to put it before the if statement, so where date equals to 01 May 1991 b, and also let's keep only some of the values, keep equals, and we are going to keep n, med, MSC, RMSC, MAPE, and MPE, and that's it. Great, so we have this cute table. Now let's do the same, but for the validation data. But the validation is always easier because we already have the code. We are going to use it there. So let's, sorry, we don't need the forecast lag because we do not have any lags there. So we'll just use the abs and stuff, you know. Let's plug them here just to get the primary calculations. We do not need to rename anything. Perfect, so we have now all of these values. Now we need to summarize them, and after that we will need to continue with the error calculations themselves. So I'm gonna just copy the last two programs that we ran, before this one. So now this is not the training values, these are validation values. We are going to use not the training data, but we are going to use the validation forecast data. Now print the same values, and instead of training, we'll create the validation sum data set. All the rest stays the same. So it's faster like this if you just copy. Great. And now here, we are going to create the validation error, the validation forecast. The date will be different, so for now let me just put the asterisk. I'm gonna keep it as a comment. After that I will open it so that we could change it somehow. So we are calling this set this one MA4 VD sum. All the rest, it seems to me, will stay. I'll just check the date that we'll be able to subset the set by. So here are the calculations. Great. And the only problem is that we do not have the date yet, but let me just check, here. Actually, I could just open the original validation set, and let's see. The first date is April 01. So that's what we are going to subset it by. Okay, so where date equals to 01 April 2001. It actually doesn't matter. It can be like any row. Great. Perfect. So now we have these two data sets, and now let's append them. Just save it. So tasks and data and append table and add table. Now we have the validationary data set here. Now we have to go to the work library. Work. And we need MA4 train error. Great. And again, let's move it on top. Let's run. Perfect. And that's exactly what we have here. So you can see that actually the distance is not so huge between MPE for the training and the validation data. It's about 7%. Here it's even about 1 for MAPE. RMSE is about 50 points. Here it's about 20,000, but that's fine. We expect it to be large. Here it's about 50. So now this is, it doesn't seem to be a bad model at all. But also let's compare this model to the others. How well does it perform when we compare it to the others? By the way, let's modify the task and let's save it permanently because I didn't do that. So we'll say BST 477 MA4 errors. That's what we need. And now we will have it in the permanent data sets. Let's just refresh them. And let's compare a few data sets to each other. So we actually had a few forecasts right before. So let's check out our naive errors. So the model wasn't really good, right? The MPE was 16% apart. I mean, the training and the validation portions. MAPE was 9% apart. MED was 200 apart. I mean, approximately. Here we can see that MSC is super different, like 100,000. Distance is pretty huge, right? Here again, our MSC is 200 apart. So the naive model is definitely not the best model for the data at hand. That's why we wouldn't even maybe use it as a benchmark model because it's not really solid, you know? So let's also check out our seasonal errors, right? Seasonal naive forecast. Here it's much better. The distance here is 4%, here it's about 8%, here it's about less than 100, right? 90 points. Here again, this is huge, but it's not like 100,000, right? And here it's again a little bit less than 100. So it's not that bad. So seasonal naive seems to be performing pretty good, not perfectly well, you know, but still it's not really that far from the reality. Also, we had our mean errors, mean forecast, when we just took the mean of the whole training data and then used it to forecast the validation data. So here we have like 10% distance, here we have 4% distance, here it's about 100 plus, here it's about 100, and again here it's not as bad as with the simple naive, so it's much better, but seasonal still wins this model because even though the model seems to be performing not so bad by itself, when compared to the seasonal naive forecast wins. Now let's check out the last model that we ran, our MA4 errors, and let's see. So here it's 7%, here it's only 1, here it's 50, here it's 50, you know, and this is perfect actually. So perhaps MA4 is really a good model, and maybe the best model out of all. First of all, we do not see a lot of data overfitting, so that means that it captured the structure of our data pretty well. And also, maybe we could try other variants, you know, MA3, maybe MA5, MA6, I don't know. We could have tried different variants and then we could have checked them, you know. So yes, we could have done that. And let's compare it to seasonal naive error. Seasonal error, sorry. So for the seasonal, this is MA4, and this is our seasonal. So we have, for example, MP is 0.6, it's negative, and 7 to 6. So this is a little bit worse for the seasonal. I mean, distance-wise, and also compared to this data set, right? For both. So MAPE is 774 for the train and 898. And here it's 4, so this is lower, but this is pretty much the same. RMSC for the seasonal is 99 or 194. Here it's 156.2, so it's a little bit higher, which is not good. But the distance here is, it seems to be shorter. Yeah, because here it's 100, there is 50. So that model is kind of doesn't capture a lot of noise, which is good. And this model is expectedly capturing the noise because, you know, it doesn't take the trend into account, right? It only took the seasonality into account. And still it wasn't so bad. That model takes everything into account, just smooth it out, and that's it, right? Smooths it out. So let's check out our math, for example, for the seasonal that we look at, right? 82 versus 179. Here it's 132 versus 184. So it seems to be, it seems that MED is a little bit worse, but because that model is much more robust than this one, I would go for the MA4 for now. But we could keep the seasonal model as the benchmark model. And the point is, it's a very simple model, you know, you don't have actually to worry much about different formulas or anything. All you need just to take the previous points from the same period of time and to predict or to forecast the next point of time. So that one is a little bit easier to understand. It's simpler. You don't need to collect any extra data, anything else. You can keep it as a benchmark model. And every time you run models, you can be comparing them to this one. So the first thing for that model to do would be, of course, to be solid, to be robust, to be consistent within itself, right? You will need to make sure that the training and the validation areas are very similar, like what we see here with the seasonal areas and also the MA4 areas. They are pretty close to each other. And then you can compare all of those data, all of those models, if you find that they're good, right, to the seasonal model to see if they are outperforming the model by a lot, right? MA4 doesn't outperform the model by much, so you can go for either of these models. I will also play with MA models, you know, and see maybe MA3 is good, MA2 is good. I don't know which one is better. Maybe there are better models than MA4. So this is the point that I was trying to cover today, and that's it for the moving average.